Hello everyone, I am Sushovan Ghosh. The title of my research is Cleaner Air would enhance India's annual solar energy production by 6 to 28 terawatt-hour. To avoid climate change, solar renewable energy is one option. And in India, the renewable solar energy is expanding exponentially. In fact, India ranked 4th in overall global capacity building. But what drives solar energy? There are clouds, aerosol and gases. My focus on aerosol. Aerosol are tiny solid or liquid particles suspended in air. But how they impact incoming solar radiation? There are two pathways. First one is atmospheric attenuation, where the aerosol particles either scatter or absorb incoming solar radiation reaching to the panel surface. And the second one is the soiling effect, where the aerosol particles either get deposited over the panel material and then reduces the panel material efficiency. If we look into the background aerosol concentration, then we found that India is one of the super hotspots. But at the same time, Government of India has taken a lot of initiative towards sustainable development. Keeping this in mind, we decided our research question could be, how does the aerosol burden impact the Indian solar resources? And to do that, we use solar radiation from the satellite remote sensing. And when we plot over the Indian region, we found that the 60% of the Indian region is actually suitable for SPP generation. But at the same time, attenuation and soiling reduces almost 1 kilowatt-hour. By avoiding this aerosol impact, we found that 89% region is actually suitable for SPP generation. So, avoiding almost two decades of aerosol burden leads to additional 29% region suitable for SPP generation. But the question is, how do we get rid of these aerosol-induced losses? One option could be the effective usage of already existing policies. Here we consider Pradhan Mantri Ujjwala Yojana, National Clean Air Program, or meeting the WHO AQJ. We further extend our research to different solar panel settings, such as fixed tilt, single-axis tracker, and the dual-axis tracker. Coming to the first-hand economic assessment, the left-hand side is the losses due to aerosol, which is 12% to 41%, translating $245 million to $835 million. But the right-hand side is the gain due to implementation of different policies, like combining NCAP and PMI lead to 16% to 42%, translating $325 million to $845 million. And combining the WHO AQJ, we found the 10 to 28 terawatt-hour. So the key findings of our research is air pollution has a visible impact in Indian solar resources, and gain in energy output is a new co-benefit opportunity. We further communicated this research to a peer-reviewed publication, and it has been highlighted in many media and newspapers. Finally, I would like to acknowledge my supervisor, collaborator, co-authors, IITD, HPC, PMRA funding, and TRIST IITD for the platform. Thank you.
We might learn from the others as well in this particular. The first prize goes to Priyanka Saini, right, who talked about improving the toughness and bulk and the plasticity of bulk metallic glass. The second prize goes to Sushovan, Ghosh, who presented on cleaner air would enhance India's solar energy production by 6 to terawatt-hours, right? And the third prize goes to Anusha Jain, who presented on designing better